There's a very good reason that we do practice problems when learning math. There are a lot of skills that just get easier and easier the more you practice them. So the more dimensional analysis problems you can practice on, I promise the better you will get. Eventually, it'll just be a piece of cake. And these are two classic dimensional analysis problems, in that we're being asked to convert something, in this case, amounts of weight. So for the first, we are given 138 ounces and asked to convert it to pounds, so we're going to need a conversion factor. And we look up some conversions in a table, and we find that 1 pound corresponds to 16 ounces. That means that we can write one of two conversion factors for use in this conversion. We could write 1 pound over 16 ounces, and that's a way of saying 1. Or we could write 16 ounces over 1 pound, and that's another way of saying 1. To decide which of those conversion factors is going to be more useful, we'll start with the measurement we're given, and it's in ounces, and we want to get rid of ounces and change that to pounds. Sometimes it helps to write as a fraction with denominator 1, which really emphasizes now that the ounces that we want to get rid of is in the numerator. So if we're going to get rid of ounces from the numerator, we need to have ounces in the denominator, which tells me that this is a conversion factor we want, the one that has 16 ounces in the denominator and 1 pound in the numerator. Now, the ounces are going to divide out in this calculation and leave behind pounds, which is what I wanted. And numerically, now I can see the calculation I need to do is 138 divided by 16. And that is 8.625, so I conclude that 138 ounces corresponds to 8.625 pounds. In the second part of this question, we're asked to convert 36,800 grams to tons. Now I can't do this directly in one step like I did the first part because I don't have an equivalence between grams and tons. In fact, if you look over the table of equivalences within the lesson, the only thing we really know about grams is that 28.3 grams corresponds to 1 ounce. So I'll write that equivalence up here because I know I'm going to need it in a little bit. 28.3 grams equals 1 ounce. Now, what that tells me is if I'm going to start with a measurement of 36,800 grams, if I'm going to do any conversion at all, I have to start with grams in the denominator to eliminate grams, which means I don't have much choice. I have to do 1 ounce over 28.3 grams, and that will eliminate grams as my unit and leave behind ounces. Well, I don't want ounces, but it's at least a start. What I want is tons. Well, the equivalence I have for tons is that 2,000 pounds is 1 ton. That leads me to believe that if I can convert this measurement to pounds, then I'll be in good shape. Well, I already know how to do that. That's the first part of the question. I converted ounces to pounds by using a conversion factor that has ounces in the denominator, 16 of them, compared to 1 pound in the numerator. That's going to eliminate the units of ounces. Now I just got one more step. I don't want pounds. I have them in the numerator. I better put them in the denominator. I want tons. Well, my equivalence is that 1 ton corresponds to 2,000 pounds. So pounds now are gone. Now I'll double check before I do the calculation. Grams and grams divided out, ounces and ounces divided out, pounds and pounds divided out. Whatever this calculation ends up being, I'm going to be left with tons. To do the calculation, I take the 36,800 in the numerator and divide by the product of all the things in the denominator. So I do 36,800 divided by the product of 28.3, 16, and 2,000. And if I choose to round to 3 decimal places, that works out to be 0.041. The units are tons. I know that because all the other units have divided out already, leaving behind tons, and that's good because that's what I was asked to find. So I conclude that 36,800 grams corresponds to 0.041 tons.